Hello, in this video let's discuss third question of today's contest. You are given a string S of length m consisting of digits. You are also given 2D integer array queries where queries of I is L of I, R of I. For each queries of I, extract the substring S of Li, Ri, then perform the following. Form a new integer x by concatenating all the non-zero digits from the substring in the original order. If there are no non-zero digits, then x is equal to 0. Let sum be the sum of digits in x. The answer is x into sum. Return an array of integers answer where answer of I is the answer to the ith query. Since the answers can be very large, return it modulo 1 in n plus 7. So given a query range, we have to add all the numbers which are non-zero in that range to a new string, and then we have to multiply that with the sum of digits in that, and we have to do modulo 1 in n plus 7, and that is the answer for that query. So for example, let's take 10203004 and queries are 07. So from 0 to 7 we can remove all the zeros and the string left is 1234. So simply the new string is 1234 and the sum is equal to 10. So the answer is 12340. And similarly for all the queries, if there are only zeros in that range, then we can simply return 0. So how can you do this? So firstly, if we clearly observe, zeros are useless, right? Because we have to form a string without zeros. Given a range L to R, we have to find a new string without zeros in this, so no need of 0 in this, and also we have to multiply with the sum. So even with sum, no use of any 0, right? So because zeros will not affect the sum. So simply from this what we can understand that zeros are useless. So what if we try to add a new string without zeros? Why to create a new string? So let's try to create a new string without zeros. So if we try to do that, the only thing that we have to do is we have to get the new query as per the new string without zeros. So for example, if we have 1020 10203 and the query is 2 comma this one 2 comma 0 2 comma 3. So in the new string without zeros, what will be the range? The range will be only 1 comma 1, right? So this is the one that we have to do. So let's check how can we do that. So if for example this is the given string and this is the range 2 to 9, after removing zeros the range will be 1 to 5. So the only thing left is how to find it now. So let's try to store a vector with values non-zero indices, right? So here let's maintain two vectors. The first one is indices with value 0 in the given array and in the given string, and the second one is non-zero values. So coming to zeros, in which indices the values is 0, 1, 2, 4 and so on. So 1, 2, 4, 7 and 11, and non-zeros is this one. So if we try to maintain these both, then we can try to get the new query, right? Because in the given range we have to filter the zeros, we have to remove the zeros, and then we have to return the new query. So let's try to store this and let's try to find how to find the new range. So this is the new vector without zeros. So initially we want from 2 to 9, right? So firstly we have to find the index in this range which is non-zero, because from then we can try to get the filtered range. So firstly we have 2 and 9, so we can try to find the index which is the first index from 2 to 9 which is non-zero, that means which is present in this. So we have to find the number which is more than or equal to 2 in the given vector, in the vector where we formed, which are indices without zeros. So in this way we can find the first index which is which is more than or equal to 2. So this is the first index, right? So what is this index? This index is simply the index that we are searching for, because in the given range we can have many zeros and non-zeros. So if we try to find the lower bound of index which we have, then that is simply the index which is non-zero, and simply that is what we are storing in that also, right? So that is 2. So in this way we got the first value. And what about the second one? The second one is also simply, so in the range 2 to n, in the range 2 to 9, we have to find the last we have to find the last index, we have to find the highest index from this array that lies in this range, so that will give the last index of the new range. So from this what we got, we can simply use upper bound lower bound. So for the first index we have to find the we have to find the number. We have to find the number in the new vector, which is indices without zeros, which is more than or equal to 2, which is the li of the initial query. And to find the final value, let's say we want 2 to 9. So how can we find the highest value which is non-zero? So we can get the value which is less than or equal to 9, right? So we have to find the highest value which is less than or equal to 9 in the vector which we found. So if we found that, then that is the indirect index that you are searching for. So how to find the value which is less than or equal to 9 in a sorted array? So simply, what is less than or equal to 9? It is simply more than 10 minus 1, right? Because if we are finding more than or equal to 10, so what that is mean? It indicates the upper bound. So indicates upper bound means it returns an index which is it returns the lowest index which is more than or equal to 10. So if it returns the number which is equal to 10, then if we try to take the before index, it means that it is more than or equal to 9, right? Like it is 9, because if upper bound returns exactly, sorry, if we try to find, we want less than or equal to 10, less than or equal to 9. So what if we try to find upper bound of 10, upper bound of 9, upper bound of 9, upper bound of 10, lower bound of 9, and lower bound of 10? Let's try to check all this and let's check which will suit this. So upper bound of 9, so what it will return? It will return the index which is more than or equal to 10, right? And what this will return? This will indicate more than or equal to 11, and this will return more than or equal to 9, and this will return more than or equal to 10. So what we exactly want? So for now let's check this one. Let's check if this can give the correct value or not. So let's check this one. So if this returns 10, for example, if this is returning index and the value at that index is 10, so if that is 10, then can you take the before value? Because that will be 9, right? Because that will be 9 or 8 or anything which is less than 10. Else the lower bound would have written this one. As this returned this, it means that the before index is not 10, and surely that is less than 10 because the array is sorted. And what if that returns a value 11? Because this will return more than or equal to 10, right? So that can be 11 also. So what if it returns 11? So can we blindly take the before one? Can we try to take the before one? So this will be not 10, right? Because if there is 10, it will return this only. If that is returning 11, it means that there is no 10. So this can be none on it. So this is what we want, right? So we want the highest index which is in the range and also which is in the given vector. So this can be done by simply upper bound, or we can simply use binary search and answer. So let's say we got an index mid. So given this index mid, we will check if this is so given range 2 to 9, right? Given it to 9. So let's select the middle index 5. So we will check if 5 is non-zero or not. So if there is non-zero, we can try to move lower high, and then finally we can get the highest index which is in this range. So hope you got this. In this way, given initial range, we can find the middle range, like in the new range, which will be suitable for the new vector without zeros. And now, so hope I already said this. We can find anything or any of these using upper and lower bounds. If that is more than or equal to, we can simply use upper bound, lower bound. If that is less than or equal to some value, we can use upper bound minus 1. Upper bound minus 1, because upper bound will return more than or equal to the value, and then by taking the before index, this will be indirectly less than or equal to that value. And now we got the effective range also. So we got the effective range, and now what we have to do? So simply we have to find the string that is appended because of this range, and then multiplied by some of these values. So that is what we have to return, right? So how can we get this? So now we have to find the string from I to j. So we have to traverse from I to j, and we have to append in the string. So that will be n square, because what if there are no zeros and the every query is 0 to n? So in that way, if that is the case, then for every query we have to traverse whole the string, and we have to find the string, and we have to traverse all the queries. So it will be n square, which we cannot do. So how can we reduce this? So this is the first problem. And then secondly, can we find the sum of numbers from index I to j in the new vector? We can find simply using prefix sum, right? So let's say we got 1 2 2 3 4, and now we want the sum from this to this index. So how can we get? We can simply store the prefix sum and then we can do. So the sum till now is 1, sum till now is 3, till now is 5, till now is 8, till now is 12. So if we try to use what is prefix sum? Prefix sum is simply the sum from index 0 to that value. So this is the prefix sum of this index, this is the prefix sum of this index. For example, if we want the sum from index L to R, what can we do? We can simply find the sum from 0 to R, and then we can try to find the sum from 0 to L minus 1, right? So we can find from 0 to R minus, we can find from 0 to L minus 1. So if we subtract this both, then what we'll get? We'll indirectly get for all indices from L to R, right? Because in 0 to R, all these are included. L minus 1, L plus 1, all these are included in this. And in 0 to L minus 1, only till L minus 1 are included. So if we subtract this both, then we'll get only from L, right? So we'll get only L plus 1 and so on, which we exactly want. So this is easy. Sum of numbers from I to j is simply we can find in O of 1. So the next thing that we have to do is we have to find the string formed from I to j in O of 1, not in O of n. So that is what we want. And how can you do that? So we want the string from I to j in O of 1. So if we clearly observe, this is also similar to prefix sum, right? Because for example, if we try to store something till here and something till here, we have to find something in the range. So similar to prefix sum, but not this. So how can we get that? So let's try to store the decimal value itself now, right? So let's say we are at 1, we will store 1. If we are at 2, we will store 12. If we are at 3, we will store 1 2 3. If we are at this 3, we will store 1233. So if we try to store all like this, the first thing is the numbers will overflow, right? Because we can store only till 1e18 or something, but the numbers can up to be 1e5. So we cannot store every value. This is 10 power 5. This is 18 digits. So this is 10 power 5 digits, this is 18 digits. So all values will overflow. So what if we try to store the values with mod 199 plus 7 as the prefix sum of that value, right? So for example, let's say we had 1 2 3 3 3 and so on. We have 100 threes. We have 100 threes, right? So for this value, what will be the prefix value? It will be 1. For this, what will be prefix value? It will be 12. And for this, it is 123. And for this, it is 12,333. And for this, it will be not 1 2 3 3 and so on. We will store the value with modulo 199 plus 7, because indirectly we have to return the answer modulo 199 plus 7. So we can do these operations by 199 plus 7, so that final answer will be correct and there will be no overflow. So what if we try to store some new value x, which is 1 2 3 3 3 3 3 and so on, modulo 199 plus 7. So if we store something like that, then can we find the answer? Then yes. How? So let's say we have 1 2 3, right? So we want the answer for this. We want only the answer for this range. So what is the answer for whole range from prefix 1 to this 3? It is 1 2 3, because we stored 1 2 3. And what is the answer for before index? Then starting, it is 1. So the answer for full is 1 2 3. The answer for before is 1, but we want only middle one, which is 23. So what is that we want exactly? So if we clearly observe, it is simply 123 minus 100, right? So 123 minus 100. Why minus 100? Because we have 2 digits in this range. So we have the answer for this. We have the answer for this as 1 2 3. But indirectly, what is the answer for these two except these both? It is like 100, right? So this is 100. This is like 2. This is like 3. Because that was exactly the binary decimal value indicates. So this is 123. So the answer till LSB plus 2 is 100, and the LSB is 2 and the LSB is 3. So if that is the case, only then the value will be 123, right? So in this way, what can we do? So if we try to store the prefix sum of every value with modulo 1 by 7, we can find the For example, we want the range from 0 to this. So without traversing in often we want an off one. So what we thought of off one, so what if we try to store the value from 0 to this one? So let's say this is 1 to 3339. So if this is the number for this, what it means, and we want only the answer for this, so we can assume that this value is this one, this value is this one, this value is this one, right? This is the last value. So what will be the answer for this value? It is simply 10 power the number of digits in this. So hope you got this. Let's finally discuss a small example. 1 2 3 3 3 4, right? So for this, what will be the value? It will be 1 2 3 3. This is the modulo 1/7 value only, right? So 1 2 3 3 3, and then we have this one, which is 1 2 3. So we want only for 3 3. So how can we get from these both? So we want only for 3 3, right? So we want for 3 3, and from prefix we have 1 2 3 3, and in till here, till before, we have 1 2 3, but we only want for the middle, right? So how can we get this? So that is simply 1 2 3 3 3 minus 1 2 3 into 100. Why into 100? Because this is the value for before one, and we are appending 2. It means it is indirectly shifting, it is indirectly multiplying by 100, right? Because initial value is x, and we are appending some value here. So what will be new value? It will be simply 10x plus new value. And now if we add other value, what will be the new value? It will be simply 100x plus 10 into this value plus this value. So simply if we want the middle value, so total value minus this value into 10 power this value. So indirectly it will give this value. So something, some binary, some decimal value, and this is what we want, and this is what we have. So how x and question mark will combinedly form y? So simply x into 10 power number of digits in question mark plus the answer we want is equal to y, right? Because that is what exactly decimal is. So if we have 1, if we append 2, what will be new value? It will be simply 1 into the 10 power number of digits we added. Because if we add 3 digits, 1 will be shifted 3 times by MSB. So product will be multiplied by 10 power 3. So hope you got this. So in this way we can find the original value still prefix, and then we can do this minus this into 10 power number of digits in the query we want. In that way we can find the middle value of 1. So in this way we can find all of the things, right? So simply now exactly what we are storing. So we are storing prefix sum vector because we want the sum from I to j, and then we are storing prefix number also for the vector. So indirectly it will store the number from 1 index 0 to that in 1/7 modulo. And we want prefix power 10 also. Why? Because let's say we want the answer for 1 to 100. So let's say we have to find the answer for 4 to 100. So we already have the answer from 1 to 100. We also have an answer for 1 to 3. But one thing we are missing is we want the 10 power 97, right? Because this length is 97. So we want 10 power 97 in 1/9 modulo 7. So that we can subtract this minus we can do this into this modulo 1/7, which is exactly what we want. So we want 10 power all in modulo 1/7 also, so that we can do modulo multiplication and then we can get the answer. So hope you got this. Let's check the code. So now what we are doing, so firstly, if traversing through n, if that is not 0, then p dot pushback, push the indices which are not 0 and push the values which are not 0. So now then find the size of both, size of the given queries and size of the vector without zeros, and now form the prefix sum, prefix value, prefix power, and answer of queries. And then we can do all these if there are at least one non-zero values in the given string, right? So enter this only if m. So if only m. So what is m? M is simply the numbers in size, the size of this vector. And what does this size of this vector mean? it means that number of non-zero digits. So do this calculation only if we have at least one non-zero. So we entered inside because we have at least one non-zero, and then initialize all the values. So prefix sum of 0 and prefix value of 0 is equal to d of 0. And now traverse through all the indices and then find the prefix sum. So if we have prefix sum till before value, and we have got new value, so what will be prefix sum of new value? It is simply prefix sum of old value plus present value. So prefix sum of I is equal to prefix sum of before plus d of I, and then we want the prefix value also. So now what will be prefix value? So let's say the number is 1 2 3 till now, and we got a new value 9. So what will be ultimate value of this all? So now also it will be simply 1 2 3 into 10 plus 9, right? So why into 10? Because we are appending a new digit, so it will be 1 2 3 9. And now for example, let's discuss, we have 1 2 3 9 also, and we are getting new value 4. So now what will be prefix value of all these? So now also it will be simply 1 2 3 9 0 into 10 plus 4 modulo 1 plus 7. So simply prefix value of before into 10 plus d of I, because we are appending new integer at the end. So multiply whole before by 10 plus present value, so into this plus 10, and then we have to find the 10 power also in 1 plus 7. So simply use a static loop 1 to m, and then pw is equal to pw the prefix multiplication of before into 10, right? So this is simply 10 power that number, 10 power 2, 10 power 3, 10 power 100 modulo 1 plus 7 for index n. So simply we done this both, and then loop through all the queries, find the lower index and upper index, and then find the lower bound of before value, upper bound of higher value, minus 1. So this will return more than or equal to that index, which we exactly want, right? So we have the initial query, we got the query which we want without zeros, we got the filtered query. So now if A is more than B, it means that there are no zeros in that range L to R. So if there are no zeros, so the answer is 0. So simply answer 0, continue. Else we came this here only if there is at least one non-zero. So what can we do? So here firstly we want the prefix sum, like we want the sum from A to B. So how can we find sum of A to B? It is simply prefix sum of B minus prefix sum of A minus 1. So simply prefix sum of B minus prefix sum of A minus 1. So if A is 0, it is 0. If that is not 0, simply prefix sum of A minus 1. And then now what we have to do? We have to find the ultimate value for this range in of 1. So how can you do that? If A is equal to 0, it means simply prefix sum of B, because let's say we have 1 0 1 2 3 4 and so on. We got the range as 0 to 4. If we got this is already stored, because this is what exactly prefix value, right? So if that is 0, not of any computation. So if the initial value is 0, so simply the value is prefix sum of 4, prefix value of 4. So if A is 0, value is prefix value of B. Else if it is not 0, then what? Then prefix value of B minus prefix value of A minus 1 into 10 power the number of digits in this query. So let's say we have 1 2 3 4 4, and we want the answer for 1 3 4 4. So we have the answer till here as 1 2 3 4 4, and we have the answer till here as 12, but we want 3 3 4 4. So simply what is that? So 1 2 3 4 4 minus 10 into 10 power 3. What is this 3? 3 is the number of values in this query, which is 3. So minus 12,000, which is 344, which is exactly this one. So simply we got value also, prefix value of B minus prefix value of A minus 1 into 10 per digits, modulo 1 plus 7. And answer of I is equal to simply multiplication of this both, modulo m. So hope you got this. If you have any doubts, comment below. See you in the next video.